CNN and ACT Media provided a television channel targeted to individuals waiting in supermarket checkout lines. The channel showed news, short features, and advertisements. The length of the program was based on the assumption that the population mean time a shopper stands in a supermarket line is 8 minutes. To test this assumption, a sample of actual waiting times from 120 shoppers showed a sample mean waiting time of 8.5 minutes. Assume the population standard deviation is 3.2 minutes. Find the p-value. Does the p-value support that the time spent waiting in line differs from 8 minutes? So our population as people standing in supermarket checkout lines. Let's let mu be the mean time spent in line. A sample was collected, so we have a sample of 120 with an average time of 8.5 minutes. We want to see if the p-value supports that the time spent waiting in line differs from 8 minutes. So my alternative hypothesis will be mu not equal to 8. What they're assuming is that mu is 8. There may be some evidence that mu is not 8. I'm thinking of this as a two-tailed test because in this statement, does the p-value support that the time spent waiting in line differs from 8 minutes? Now, being different than 8 means that it could be larger or it could be smaller. So I've got a two-tailed test here. But actually, it's just asking me to calculate a p-value. It's not giving me a level of significance. So I really don't have any decision lines to set up here. I am assuming that the null hypothesis is true, so the center of this distribution is 8, and I do have a measurement for the standard deviation of the sampling distribution would be 3.2 divided by the square root of 120. To get a p-value, all I need is the test statistic for my sample mean. So I have 8.5. How far is 8.5 from 8? In standard deviation units. And this value turns out to be 1.71. So the location of my sample mean is about 2 standard deviations to the right. So 8.5 is 1.71 standard deviations to the right of 8. The p-value is associated with the area measured to the right. Now remember, this is a two-tailed test, so whatever this area is has to be doubled to get the actual p-value. I need to use the standard normal table and look up the 1.71 and find this upper tail area. So my z-value is 1.71. That would be in row 1.7 and column 0.01. So again, this area from the center out is 0.4564. The area I want is 0.5, subtract 0.4564, and that will give me 0.0436. So this area is 0.0436. But that's not the p-value because this is a two-tailed test. The p-value is equal to 2 times 0.0436, which equals 0.0872. Now, the conclusion is my p-value is 0.0872. Is that significant? Would you go ahead and reject the null hypothesis? Maybe some people would, maybe some people wouldn't. It really depends on where you personally would set your level of significance. There was none given in this problem. So it's really up to the person interpreting the p-value as to what they're going to do. When you look up statistical research, A lot of times people will run tests. They will not state a level of significance. They'll just state the p-values that they obtained from their samples and let you be the judge. The person running a hypothesis test is the person who sets alpha, the level of significance. That, remember, is the risk that they're willing to take of making a type 1 error. And that's based on the person running the test. It's their decision. In this case, we weren't told to set alpha to any particular value. So really the decision here is up to you. 0.0872, if we were setting alpha to be equal to 0.05, then this is too much risk, and we would not reject the null. But if we were setting alpha to be 0.10 or 10%, then we are within that risk of making a type 1 error and would go ahead and reject the null and say that there is a difference.